Good evening everyone, myself Gautam Sharma. I welcome you all in Sapiens Education. So today I am going to solve NCERT questions of electromagnetic wave. So let's go for question number 1. Question number 1 itself said that in figure 8.5, so this figure we are talking about, this figure shows a capacitor made up of two circular plates, each of a radius of how much? 12 centimeters. So this is the radius of the circular capacitor separated by a 5.0 distance. So this is 5.0 centimeter distance, right? So this is the distance, and the capacitor is being charged by an external source not shown in a figure, and the charge current is a constant of 0.15 ampere. So current I is equal to 0.15 ampere is there, right? We need to calculate the capacitance and the rate of change of potential difference. So let's first of all, whatever they have provided you, we will take that. So radius is equal to 12 centimeter. So we can also write 0.12 meter, right? And after that, d is the distance. D is the distance between them. So let us suppose D is the distance and the distance between them is 5 centimeter. But if you want to convert it into meter, so you will have 0.05 meter, right? And the current they have provided you as a 0.15 ampere. And epsilon naught, if you want to find epsilon naught, will be required for solving a problem. So this is equal to 8.85 into 10 to the power minus 12 Coulomb square Newton inverse meter minus 2, right? Now the thing is that they are asking you capacitance of the capacitor. So what is the formula for the capacitance of the capacitor? So we know very well that the capacitance of the capacitor is equal to epsilon naught A divided by B, right? So the thing is that we need to put the values 8.85 into 10 to the power minus 12 into area means pi into radius square means 0.12 whole square. After that, the distance is equal to 0.05. Now you need to calculate it. So if you try to calculate it, so you will get capacitance is equal to 8.0 into 10 to the power minus 12, or we can say that it is 8 picofarad. So this is the capacitance of the capacitor. So I hope you have understood this one. Now the thing is that they have also asked one more important thing in this question, that rate of change of potential difference between the plate, that is dV by dt they are asking, right? Rate of change of potential, right? How to find this? So let's go for a basic formula. So the basic formula we have is Q, that is charge, amount of charge is equal to C into B. Now differentiate both the sides. So if you differentiate both the side with the respect to time, so this will be dq by dt, and this is equal to C dV by dt. Now we know very well that the rate of change charge is equal to current, and this is equal to C dV by dt. Now from here, C dV by dt. Now from here, we can easily say that dV by dt is equal to I divided by C. So this is the formula we need to find now. I dV by dt. So just put the values of the put the values, you will get dV by dt. So dV by dt is equal to current. They have provided you 0.15 ampere divided by capacitance. Capacitance, just now we have 8 picofarad. So we can write here 8 picofarad means 8 into 10 to the power minus 12. Now just calculate it. So this will be approximately 1.87 into 10 to the power 10 volt per minute, 10 volt per second, right? Just calculate it by your own so that you can get it. You won't be confused. So dV by dt, we have got it. So the question, part A question for this question has been solved. So this question has been solved, that is A has been solved. Now next they are asking obtain the displacement current across the plates. What is displacement current? So since this plate has been connected with the current source, so the normal current itself is I, and this is equal to 0.15. but there is no connection between this one. So how this conduction happens? So this current is considered as a id, that is displacement current, right? That is displacement current, right? So I will solve this one. So how to solve this one? So first of all, this is part B question. I will start step by step. Displacement current id is given by displacement current. If you gone through the theory, so you will find displacement current will be represented by d, and it is not direct conduction because there is no material for the traveling of the current, right? So if you observe this one, this figure, so there is no current and no conduction material between the plates are there, so that's why the current passing through this one is considered as a displacement current. And we know that displacement current, that is id, is equal to epsilon naught into d phi of by dt, right? That is change in electric flux is divided by dt, right? So d phi by dt, how to find the d phi by dt? The thing is that we need to, if you want to find a d phi by dt, so we need to go through the basic formula, that is phi e is equal to e into a. D phi by phi e is what? Phi is your flux, electric flux. So phi is equal to e a. Now electric field E is equal to what? E is equal to V by D. We know this one. So we can write here V by D into A, and this is equal to phi E. Now we want phi E by phi d phi E by dt, right? Now we can write here d phi E divided by dt, and this is equal to A by D into dV by dt. Now dV by dt we have already find out. So we need to find the area as well as d. What is the area of the capacitor? So radius is already they have provided you. Radius they have provided you as 0.12. So from here we can get the area. So area will be pi into r square, means 0.12 whole square, divided by what is the d, that is distance between separation is how much? 0.05. 0.05. So this will be 0.05 into dV by dt, means just dV by dt, right? Now put whole value in here so that you can get the result properly. So let's start putting this. So from here id, that is current, will be equal to epsilon naught. Epsilon naught means what is the value of epsilon naught? 8.85 into 10 power minus 12. So put the value 8.85 into 10 to the power minus 12 into d phi e by dt can be rewritten like this. See, d phi e, that is change of flux, electric flux with respect to time, rate of change of electric flux, can be rewritten as here pi into 0.12 whole square divided by 0.05 into dv by dt. Now put the value of this one, dv by dt. So displacement current is equal to 8.85 into 10 to the power minus 12 into 3.14, that is the value of a pi, into 0.12 whole square into 1.87 into 10 to the power 10 divided by 0.05. Now just pause the video and try to solve this one. So while solving, pause the video first of all, so you will get a displacement current. When you solve it, so you will find the displacement current 0 is equal to 0.15 ampere. Got it? So I hope you have understood this one. Now let's try to solve the next question, next part of this question. Next part of this question is that is Kirchhoff's first rule, junction rule, valid at each plate of the capacitor? So in each plate of a capacitor, is Kirchhoff's law is valid or not? We need to write this. Okay. So in this section, is Kirchhoff's law is valid or not? So this is the part C. So we will discuss part C of this question. Okay, so let's discuss this part C. Now first you need to understand that validity of Kirchhoff's law, that is junction rule. Kirchhoff's first law rules state that the total current entering the junction must be equal to total current leaving. So let us suppose there is a capacitive circuit and there is a current which is flowing from one direction to another, and the current they have already provided you 0.15. Got it? And if current entering is equal to 0.515 and the current is also coming out as a 0.15, right? At each plate of a capacitor, the conduction current is equal to 0.15 because 0.15 amount of current is going inside. And the displacement current, see, displacement current means the current without connection is also equal to 0.15. So it means that the current will also come out as a 0.15. It means that this suggests the validation of the Kirchhoff's law. So there is no physical movement of the charge across dielectric, but change in electric field produces an displacement current. And this displacement current and conduction current both are same. So that's why Kirchhoff's junction rule will be followed in this type of situation. So I hope you have understood this one. So pause the video and just write whatever I have written. So let's go for next question, and next question is 8.2. The 8.2, the question number 8.2. In this 8.2, the parallel plate capacitor. So this is the parallel plate capacitor in figure 8.2, made up of circular plate, each of a radius of 6 centimeter, and the capacitance of the capacitor is 100 picofarad, and the capacitor is connected to a 230 volt AC supply with the angular frequency. Angular frequency means that they have provided you omega. So what is the RMS values of the conduction current? That is RMS. And is the conduction current is equal to the displacement current? Definitely. See, here Kirchhoff's law will be followed. So definitely it will be equal only. Determine the amplitude of B at a 3 centimeter from the axis of the parallel plate. So let us suppose this is the axis of plate. So we need to find a B at the distance of this one. So just let's go and solve each and every problem step by step. So before you solve or before you come to the problem, so you need to write all the specific data what they have provided you, right? So first of all, they have provided us a radius that is equal to 6 centimeter, and this can also be written as 0.06 meter, right? And the capacitance of the capacitor is equal to 100 picofarad, and if you convert it into standard unit, so this will be 100 into 10 to the power minus 12 farad. And the voltage, that is Vrms, they have provided us Vrms as equal to 230 volt. So I hope you have understood this one. And the omega they have provided you is 300 radian per second, right? Now the thing is that IRMS, so we need to find IRMS. So IRMS will be equal to what? IRMS will be equal to what? Since it is your capacitive circuit, so the resistance, that is resistance will be Xc, and this will be equal to omega C, right? Now we know that general formula for the current is equal to V into IR. B is equal to IR. So from here we can write V, in place of V we will put V RMS, and this is equal to I into RMS into, in place of resistance, which type of resistance will be we have? Xc, that is capacitive resistance. Again from this we can rearrange the equation so that we can get the result. So they are asking IRMS. So from here we can say that IRMS is equal to Vrms divided by Xc. Now Xc is equal to 1 by omega C. Xc is equal to 1 by, actually Xc is equal to 1 by omega C. Sorry for that, I have already done this mistake. So try to understand here. Xc will basically, that is capacitive resistance, will be equal to 1 by omega c. So from here we will get 1 by omega c means Vrms into omega into c. So from here we will get the result for the RMS values. So Irms is equal to voltage RMS, that is equal to 230 into voltage RMS into omega, that is equal to 300 into capacitance, and capacitance is equal to 100 into 10 to the power minus 12, right? So I hope you have understood this. Then you multiply it 200 into 300 into 100 into 10 to the power minus 12. So I hope you will get 23 into 3, 3 3 is 9, 3 2 is 6. So approximately is this you will get as a 6.9 into 10 to the power minus 6, or you can say 6.9 microfarad. So this is the value of RMS values. So I hope you have understood this very well. So thank you. Let's go for next problem. Next problem, it is saying that B, that is the conduction current is equal to the displacement current. Yes, the answer should be yes. Why yes? Because whenever you just now previous question I have discussed that it conduction current is equal to 0.15 ampere. So here also the conduction displacement current will be also 1.5 because it follows the Kirchhoff's law. So you have to be very clear about this, right? So definitely it is yes here. So our answer should be for this one is equal to yes for part B. For part B of this one, yes, conduction current will be equal to the displacement current. Conduction current will be equal to displacement current, right? So I hope you have understood this one. Now let's go for next question. Next question they are asking, determine the amplitude, that is amount of amplitude B at a 0.3 centimeter from the axis between the plate, that is strength of the B. So which type of formula we will use? So I think if you want to use this formula, so you can use this formula as well as magnetic field B, magnetic field B. So let us suppose this is a parallel plate capacitor, there is an axis, and from this axis we want a magnetic field strength at this point, that is B. So this can be given as mu naught I divided by 2 pi r square into I naught, mu naught r into I naught. So this distance they have into I naught into the distance d. Now this distance they have provided you. See, mu naught we have, mu naught is equal to 4 pi into 10 to the power minus 7, 4 pi into 10 to the power minus 7, and the distance d they have given you as 3 centimeter. So this will be 0.03 meter, and I naught is equal to root 2 into IRMS. So IRMS they have provided you how much? IRMS they have not provided, but we have already found this RMS. So this is equal to root 2 IRMS. So this will be equal to 6.9 into 10 to the power minus 6 into root 2, right? So this is the I naught, that is peak current. Okay. Radius of the capacitors they have given as a radius of capacitors, how much they have given, 6 centimeter or 0.06 meter. 0.06 meter, right? Now I will put the values of each one so that we will get the result. So strength of the magnetic field, that is equal to 4 pi into 10 to the power minus 7 into I naught, that is equal to 6.9 into 10 to the power minus 6 into root 2 into distance is equal to 0.03 divided by 2 into 3.14 into r square, that is equal to 0.06 whole square. Now we will calculate this one. So if you recalculate it, or if you try to calculate it by your own, just pause the video so that you can calculate it. So this you will get 1.63 into 10 to the power minus 11 Tesla. So this is the final results for this one. So I hope you have understood this one. Now let's go for next question. Yeah, in this question 8.3, what physical quantity is the same for X-rays of a wavelength of 10 to the power minus 10, red light of the wavelength 6800, and radio wave of the wavelength 500 meter? What quantity, physical quantity? So see here, the thing is that you need to understand that what is the relations. The relation between, see here, frequency is equal to C by lambda. Now what will happen? Frequency is changing, right? Wavelength is wavelength is changing for all, but what is constant? C, that is equal to speed of light in, so speed of light. So what we can say, speed of the light is independent of, speed of light is independent wavelength as well as frequency. So it will remain constant, that is C is equal to 3 into 10 to the power 8 meter per second is will remain constant. So I hope you have understood this one. Now let's move further for the next question. In next question, see, a plane electromagnetic wave travels in a vacuum along z direction. What can you say about the direction of its electric and magnetic field vector? So first of all, we need to draw three-dimensional figure. So let us suppose this is 3 axis, this is 3 axis. So let us suppose this is x-axis, this is y-axis, and this is z-axis. Now what they are asking, they are saying that our electromagnetic wave travels in a vacuum, right? Travels. So traveling in this direction, see, traveling, EMW is traveling along electromagnetic wave, EMW is traveling along z-axis. So if it is traveling along z-axis, so what will be the magnetic field? What will be the magnetic field as well as electric field? Magnetic field and electric field will be normal to this. So if you have seen this figure, so what will happen? See here. Let us suppose this is your electric field. So this will be how much? This will be magnetic field like this. Got it? So in which plane electric field as well as magnetic field will remain? So definitely this electric field will remain in x as well as y. So x as well as y plane. So let us suppose mm, like this, there is a electric field. So magnetic field will be like this. Got it? So electric field as well as magnetic field. From here we can say that the electric field E and magnetic field B will lie in XY plane. We don't know either which X or Y, but both will lie in XY plane, and one more important thing is that both will be perpendicular to each other. Both will be perpendicular to each other. So I hope you have understood this one. Got it? Now the thing is that the second part itself is saying that if the frequency of the wave is 30 microhertz, what is its wavelength? So they have given you the frequency. So frequency is equal to 30 megahertz, not microhertz. So this will be 10 to the 6 hertz. What is the wavelength? So lambda is equal to how much? So lambda is equal to, what we know, that lambda is equal to c by frequency. So 3 into 10 to the power 8 meter per second is the speed of the wave, as well as 30 into 10 to the power 6. So finally if you calculate it, so you will find lambda is equal to 10 meters. So I hope you have got this answer. Got it? Now let's go for next further more question. uh yeah, so this is question 8.5. A radio can tune to any station between 7 megahertz to 12 megahertz band. What is corresponding wavelength? So we have frequency. How many frequency? Sorry, we have two frequency. Yeah, we have two frequency, that is 7.5 megahertz means 10 to the power 6 hertz, and the frequency 2 we have as a 12 into 10 to the power 6 hertz. So these are the two frequency. Speed of the light is equal to 3 into 10 to the power 8 meter per second. Here also speed of the light is equal to 3 into 10 to the power 8 meter per second. Now the thing is that we need to find the lambda for corresponding lambda. So when you combine this, so corresponding lambda will be how much? So lambda will be equal to c by frequency 1. So this will be 7.5 into 10 to the power 6 divided by 3 into 10 to the power 8 meter per second. So finally if you calculate it, so what will be the result? Just try to pause the video and just try to calculate by your own. So what will be the result? Just try to. I think I have done some mistake, or what? Yeah, I have done one mistake, that is just by putting value. So that's why I'm telling you, just put by your own. You know the formula now. Just put the value. C is equal to 3 into 10 to the power 8 meter per second, as well as frequency is equal to 7.5 into 10 to the power 6. So when you calculate it, so what you will get, it will be approximately, it will be 40 meter only, right? No approximation. Now let's go for lambda 2, that is wavelength of the second frequency side, right? So this will be again c by frequency 2. So this is equal to 3 into 10 to the power 8 meter per second divided by 12 into 10 to the power 6. So this will be, finally when you will calculate this, so what you will get? You will get approximately equal to, not approximately, it will, you will get 25 meters. So our wavelength will range from 40 meter to 25 meter, or just we can say reverse also. So we have got corresponding wavelength will be 40 meter for 7.5 megahertz, and 12 megahertz we will get 25. So what you have observed, that the higher frequency less wavelength, and lower frequency more wavelength. So I hope you have understood this one. So these are the two results for this question, right? Now let's go for next question, that is 8.6. A charged particle oscillates about the mean equilibrium position with the frequency of 10 to the power minus 10 hertz. What is the frequency of the electromagnetic wave produced by the oscillator? So if you want me to answer this one, so let's create an analogous to this one. So let us suppose there is a wave creator objects are there, and it is creating a ripples of the wave in the water, right? Let us suppose it has a frequency of 100 hertz. So the ripple is being created by this one. So ripple will also being created at the same frequency. Why it will change? You just create your own logic, right? Why it will change? Whatever frequency it will have. For example, pendulum is moving at one for a distance c. Let us suppose there is a pendulum and there is a obstacle. So it is taking 1 second to go and again 1 second to come here, or 2 second come here and again 2 second to go there. So this is the frequency, right? So at a certain frequency it will just hit the object, and this object will have a same frequency, right? So what we can say from here, that the frequency of an frequency of electromagnetic wave produced by oscillation produced by oscillation will be will be equal to the frequency of c of charged particle oscillation. So I hope you have understood this one. So let's go for next question. Our next question is 8.7. In 8.7, the amplitude of the magnetic field part of the harmonic electromagnetic wave in a vacuum is this one, that is 510 nanotesla. What is the amplitude of the electric field part of this one? So any magnetic wave, so we know that this is a there is a magnetic wave, so this will be created. This is a magnetic wave and it will have two energy system, that is electric field as well as magnetic field. So let us consider this is a magnetic field B, so this will be electric field. Now the important relation, so what we know about this one is that E naught is equal to B naught into C. Now they have provided you B naught, so we can easily find out E naught. So from here electric field part will be, energy of the electric part will be how much? C. B naught is equal to 510 nanotesla. Nano means 10 to the power minus 9 into speed of the light is 3 into 10 power 8. Now after that what you need to calculate it. So when you calculate it, so you will get 153 Newton per coulomb. Just try to calculate by your own so that it will be more learning for you. So try to calculate each and every problem by your own, don't copy and paste. Now let's go for next question. Next question itself is saying that suppose that the electric field, let us take the pen, yeah, suppose that the electric field amplitude of an electromagnetic wave is E naught is equal to this one, and its frequency is 50 megahertz. Determine the B naught, omega, K and lambda, and find the expression for E as well as B. Now let's go for one by one. Yeah, first and foremost important thing is that we need to know about what they have provided you, right? Okay, now let's see what they have provided you. First data they have provided you is that E naught, that is E naught is equal to 120 Newton per coulomb, and the frequency is equal to 50 megahertz, so 50 into 10 to the power 6 hertz. Got it? And determine B naught, right? Now we can assume C is equal to 3 into 10 to the power 8 meter per second is the speed of the light. So from here we can easily find out B naught. So from here what we can say, that B naught is equal to E naught divided by C, right? E naught divided by C. So from here we can say that E naught, our E naught is 120 divided by C means 3 into 10 to the power 8, right? So when you calculate it, so the amount of strength of the magnetic field, that is 3 4 are 12, so this will be 4 into 10 to the power minus 7. So if you do it in Tesla, so you can write 400 nano Tesla is the value of B naught, right? So I hope you have understood this one. Now let's go for another term. So another term they are asking, omega is equal to what? So it's again very easy. Omega means angular frequency they are asking. So angular frequency will be equal to 2 pi into frequency. So 2 pi means 2 into 3.14 into frequency. They have provided you 50 into 10 to the power 6 hertz. So 50 to the 100. So this will be 304 into 10 to the power 6, right? So this is the radian per second. Per second. So I hope you have got the values of omega. Now let's go for next values. What they are asking in this question? They are asking a k. What is k? K is the wave number, or so k is equal to basically omega by c. So this will be 314 into 10 to the power 6 divided by c is equal to 3 into 10 to the power 8. So when you calculate it, so the value will come around 1.05 radian per meter. So this is the value of k. Got it? Now what they are asking now? They are asking lambda. So lambda will be equal to what? Lambda is equal to, again same formula, lambda is equal to c by frequency. So c is speed of light, that is equal to 3 into 10 to the power 8 meter per second divided by frequency, that is equal to 50 into 10 to the power 6. So when you see, when you calculate it, so what you will get? So you will get as a 6 meter. So just calculate it by your own. So it is more advisable for you people that calculate the values by your own. Don't rely on it. The method will be same, but the thing is that in calculation there may be a error. So just you need to find out. But I hope there is no error. But at least go through and do it by your own, so that it will be beneficial for you, right? Now next part of this question is find the find expression for electric field as well as magnetic field. So what is the expression for the electric field and magnetic field? So see, previously what they have given, B naught is equal to 4 into 10 power minus 7. So okay, whatever data they have given you, just use that data to find out the equations. So first, expression for electric field. Okay, we will go for expression for electric field. Expression for electric field, E. So E will be how much? E will be equal to the maximum electric field, that is E naught into sine kx minus omega t. Omega t into j direction, right? So let us suppose this is j direction, because we can consider the propagation of wave in a x direction. So propagation of electric field will be in j direction. That is, x means I direction. Electric field propagation will be in j direction. So we can put the values. So let us put the value. E is equal to how much? E naught is 120. So just I have given 120 into sine k means how much? K means 1.05. So all are in standard units, so don't worry. uh, X minus omega, again omega check, omega is equal to 314 into 10 power 6, 300 340 into 10 power 6 into t, right, into j cap. Now we need to know about the expression for the magnetic field, that is equal to B naught into sine kx minus omega t into k cap, because both are perpendicular. So B naught, we have already got B naught, value of B naught just now we have found that it is 4 into 10 power minus 7 into sine 1.05x minus 3.14 into 10 to the power 8 t into k cap, right? So this is the magnetic field. I hope you have understood this one. So let's do this one. So I hope it's okay now. See, so I hope you have done this one, question number 8.8. Now let's solve question number 8.9. Question number 8.9, the terminology of a different parts of the electromagnetic spectrum is given in the text. Use the formula E is equal to h nu for energy, quantum radiation and photon, and obtain the photon energy in a unit of electron volt for a different part of the electromagnetic spectrum, and in what way are the difference in the scales of the photon energy that you obtain related to the source of electromagnetic radiations. Okay, so see, basically what they are asking you, energy in terms of lambda, right, or energy in terms of the electron volt. So let us suppose the basic formula for the energy we will go through like this. Basic formula for the energy is E is equal to h nu, right? We can also write like this, hc by lambda. Okay, now just put the value of h as well as c. So we have, see, all energy is this energies are in a joule, right? So value of h, that is Planck constant, is how much? So you know, you have to remember this one, 6.6 into 10 to the power minus 34 into speed of the light is equal to 3 into 10 to the power 8 meter per second divided by lambda, and this is in joule. But what they are asking in question, just if you read it properly, so unit should be in electron volt. So to convert joule into electron volt, we have to divide it by 10 to the 1.6. We have to divide it by charge, value of charge, that is 1.6 into 10 power minus 19. So let's divide it. So when you divide it, so energy E is equal to 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 1.6 into 10 to the power 19 lambda, right? So when you calculate this, all this one, so what you are going to get, since we have already derived it in electron volt, so electric field E is equal to how much? So it will be 12.37 into 10 to the power 10 to the power minus 7 divided by lambda into electron volt, right? Got it? Now, in what way are different scales of the photon energy that you obtain related to the source of electromagnetic radiation? See, the thing is that source, see, photon energy. So let us suppose there is a source, and source 1, and it has a lambda 1. Source 2 has a lambda 2. So you will also get a different energy, like E1 is equal to this much amount divided by just lambda 1. So it's energy is inversely proportional to the lambda, and with the constant of proportionality is equal to 12.37 into 10 to the power minus 7 electron volt, right? So this is the relation. So I hope you have understood this one. Now let's go for next question, and that is question number 8.10, that is 8.10, and perhaps this will be the last question for this chapter. So let's go and solve it. Now, in a plane electromagnetic wave, the electric field oscillates sinusoidally. Electric field oscillates sinusoidally at the frequency of 2 into 10 power 10 Hz, and the amplitude is 48 volt per meter. What is the wavelength of the wave? What is the amplitude of the oscillating magnetic field? And so that the average energy density, that is E field, is equal to the average energy density of the B, that is magnetic field. So I will come later last question. So first question, what we will try to solve it, right? So in first question, what they have given you, first of all write this one. See, in first question, first part, before that we need to solve, we write the values they have given. They have given, they have given 2 into 10 to the power 10. See, they have given 2 into 10 to the power 10 hertz as a frequency, right? And the amplitude they have given you as amplitude, that is amplitude, what they have given, amplitude, yeah, is 48, that is amplitude of the electromagnetic wave electric field, that is E. They have provided you as a 48 volt per meter because they have provided you electric amplitude of the electric field, not a magnetic field, right? What is the wavelength? So let us consider lambda. So lambda will be equal to c by frequency. So c is equal to 3 into 10 to the power 8 meter per second divided by frequency is equal to 2 into 10 to the power 10 frequency. So when you calculate it, so how much it is coming? 2 is divided by this one. So this will be 0.015 meters. This is the value of lambda, right? So the first part of this question has been solved, that is A part. Now we will go for B part. What is the amplitude of the oscillation of the magnetic field? So they are asking B. We know the formula, easy formula, that is what is B? B naught is equal to E naught divided by C. So E naught we have already know that this is 48 and divided by C means 3 into 10 to the power minus 8, sorry, 3 into 10 to the power 8. So this will be approximately 1.6 into 10 to the power, it will go up. So this will be 10 to the power minus 7 Tesla. So I hope you have understood this one. So let us try to write in a proper way so that you may not get confused. Uh, let's write 10 to the power minus 7 Tesla, right? You can easily convert it into Tesla. Now, okay, so I think part B is also done. Now part C. So that the average energy density of electric field is equal to average energy density for the magnetic field. So if you want to understand from the diagram, so let us suppose this is a diagram where you will find an electric field like this and there is a magnetic field like this, or I will just show it with a different color, so I hope you it is visible. Now they are asking the average energy density for this part or the electric part as well as magnetic part, both are equal or not. You have to prove it, right? Now, if you talk about the energy density for the electric field, so what we can write, UE, basically U is equal to 1 by 2 into epsilon naught into E square. So this is the energy density for the electric field. Energy density for electric field, right? Electric field, okay. Now we will go for energy density for the magnetic field. So if you want to go for energy density, that is UB, that is equal to 1 by 2 mu into B square. So this is the energy density for magnetic field, right? Magnetic field, right? Magnetic field, okay. So this is what they have given you. Now one more important thing, that the speed of the light can also be written as epsilon naught into mu naught, epsilon naught into mu naught, right? Now just put the relation, so we know that E is equal to B into C. Got it? And C is equal to 1 by root under mu naught into E naught. Right? Just put the value of this one so that we can get. So this is E and B. Now E square. If you square it, so this will be E square is equal to 1 by mu naught into epsilon naught into B square, right? I think something I am missing here. Uh, Something I am missing here in the formula. Uh, think by yourself. I think speed light in terms of speed of light in terms of epsilon naught and magnetic field. So it's okay. No, C is there only, right? Okay. Okay, no issue at all. Right. Right. So let's E square is equal to this one, right? Now can we say that mu, so B by mu, so epsilon naught, yeah. Epsilon naught. Yeah, we can write now epsilon naught into E square is equal to B square by mu naught, right? Now just multiply it by half. So what we will get, 1 by 2 into E square into epsilon naught is equal to 1 by 2 into B square by mu naught. So now just check it. What is this? Energy density formula for electric field and energy density formula for the magnetic field. From this, what we can infer that UB is equal to UE. So this is hence proved. So in this way you need to prove it. So this is what they are asking, they are expecting in the question. So we have shown this one. So I hope you have understood all this topic. If you have any doubt or query, just ask in a comment section below. Thank you for showing interest in our channel. Thank you for watching.